Hi everyone. So for this devlog, I worked on creating a GUI system, or at least the basis for one. And to be honest, I thought this was going to be simple since it's only in 2D, but yeah, the complexity really didn't come from drawing quads to a screen. It had to do with synchronization and working within the bounds of the bottle checker. I could have probably made this more simple for the short term if I just coded everything directly and hard coded all the GUI elements, but I wanted something that was a bit more flexible because I'll be using this for things outside the game like server selection and things like that. And since this GUI is specifically built for this game, I was able to make some assumptions that made some of the implementation less complex and become less of a general solution, but still easy to work with. And as I continue working on the game, I'll keep improving this GUI system as I add features, as new game mechanics come about. Once I had some of the building blocks done, I started building out the GUI. For example, here is the mock of the chat box. Then started the hotbar. I then needed some icons for the hotbar. So to do that, I set up a camera on a light source in Blender, and I rendered an image of what I wanted. And then with that image, I went into GIMP, and I stroked it. There were some transparency issues, but I think it came out good enough. After that, I created the health bar, which is really just a panel with a colored tile that's being shrunk depending on the health. The difficult part of this is the actual synchronization. So what happens when the health changes and how to update the GUI, which I'll explain in a bit. I then needed a couple more icons. This one's a backpack for an inventory. The next one is a cogwheel for a menu. And these are 64 by 64 pixel images that will be mapped to an array texture. And this is how all the GUI textures are done. They're grouped by dimension in an array texture and set up with a lookup in the code. And I think in game they look pretty good, and they load some mock panels. I don't really need to fill the panels now, but really wanted to set up the interaction between the button click and the panel being closed or opened. So for the design, I think the best thing is to just show how it's used and maybe talk about some of the design constraints. And this example here is the simplest example I can show to start off with, which is the menu panel, which really only has a panel and a text box. So the first thing you'll see that's done is this panel is created. And this panel is part of a retain mode design, as opposed to, let's say, an immediate mode design, which means this panel will hold state and it'll actually live through multiple frames. And in my case, it lives the entirety of the lifetime of the GUI. And I picked retain mode because I felt it was easier to debug and sort of reason about, where from my understanding, immediate mode is more about looking at conditions per frame and deciding what needs to be built for that frame. Anyways, so you'll notice with this panel, we have a couple parameters here. This vec2 is actually the position relative to its parent. So if we look down here, the actual parent is on the x -1 to 1 and the y -1 to 1. So this is defined in screen space. So all the coordinates are in screen space. So what this is saying is just take the center of screen space. And one of the things that I don't know if I like yet, maybe it's problematic, is if you're going to pick how to position these panels, you have to pick sort of a position on the panel where will be the sort of the origin of the panel. So of the elements, the center is always 0, 0 of the panel. So if I want to go midpoint, it would actually align the midpoint of the panel on top of the midpoint of the screen. So this is what it would look like. So let's imagine we have screen space here with its coordinates like this, -1. And in the example, I showed that I wanted it at 0.5, 0.5. The other parameters are width and height. Doesn't really matter right now for this example, but so I want it at 0.5, 0.5. So I want it halfway, or the midpoint on the x direction. So it's x and y, and the midpoint on the y. So midpoint in the x, let's say, is -1 and 1. That'd be 0, and y would also be 0. So you end up with a point here. So when I want to actually draw the panel, this is the position I want to draw it at. I had to kind of pick a convention, and I don't know what the industry standard is. Kind of just made the most sense to me at the time, but maybe I'm regretting it now, I don't know. For example, I could pick top right corner as the origin. That's what I meant by the origin of the panel. Or I could pick, bottom left, or anything else. But instead, what I picked was, imagine this in the center of the panel. So the center is the origin of the panel. And I don't know, again, it made sense to me at the time, but I think it's a little bit confusing to work with. So maybe I'll change that in the future, but for now, that's what I'm working with. The next part is creating this text box and updating the text. So the text box handles multi-line text, And by default, it will word wrap the text. And the way that I actually set it up is like this. So imagine I have this UI sucks. I want to fit it into this space. It could be part of a panel or the screen. We know we have a width and a height, and we keep track of a width, the current width, something called the font height, or you can think of it as a final height, which is initially set to the height over here, and the line number. What I'll do is I use this final height and multiply through using the tallest character, and then, for example, in this case, it's the uppercase T. Tallest meaning, if I were to look in the font file, let's say this is 60 pixel by 66 pixel. I'll use the final height to multiply through and create the screen space equivalents that are downscaled for the rest of these characters. So I can then place the first character at the full height of the space we're working with. The rest of the versions that still have the same aspect ratio but are downscaled, and I can try to build them out and keep summing these widths into this variable here. And eventually it becomes the case, many times, where CW is greater than W. And if that's the case, we need to actually scale down the font height, let's say by, 10%, and try these again. So let's say you scale down by 10% and you try again. And this time it's a little bit off from the top. So the font's a little smaller, but it fits a little more. So you'll keep doing this until all the font fits. And sometimes it's the case where the final font height, which is used to generate the quads and all that, the final font height ends up being less than the height of the line number +1. So if this is the case, we basically know that the font has shrunk enough to where it should be split between another line. So in this case, line number +1, and we run this again. And then this would create something like this. This UI sucks. And that's pretty much it. And I don't mind this iterative approach because this only happens when the text changes. So it's not like every frame it has to do all of this. After the text is loaded, then we can add the panels to their parents and call update positions, which I don't think I actually need this anymore, but I had it originally. And yeah, add the final panel to the UI. And you'll see I'm using a constant here, not a variable. And this is because I referenced this in another place. Yeah, right here, for example, which I'll get to in a second. And if you don't use a constant, then this ends up being a closure and not a function, which closures then I have to worry about lifetimes and Rust, and I don't know, the syntax gets a little bit uglier. So just using a constant is fine. So in this example, pretty simple, creating a panel. If we go to, let's say, another example, actually would make sense to look at the icons. So same deal, create a panel. The location is 90% to the right and just off the bottom. And this is a little bit different here. So there's some UI effects. These UI effects, what I do is, there's a couple of them. There's like color blending, translating, scaling, that sort of thing. Basically, you can assign these effects to whatever actions happen to this specific button. So if it's hovered, unhovered, pressed, released, those sort of things. And in this case, it's just a color blend. So it's just a linear interpolation between the two colors, which gives that highlighting of the button. So you can create a button. Let's say I create the inventory button. You would just assign the inventory button to its animation effects, each of these. And when an effect needs to happen, it cues the animations, whatever are in this collection here. So you could have actually multiple effects in a row that get cued. Currently, I just use color blending. In the beginning of the video, there's you can see one of the buttons moving around. That's like the translating one. Anyways, so then the button's created. And then here we have the icons. And the way it works is I create a array texture for different sizes. So I've got 256 by 256 and 64 by 64. And this gets picked up in the shader, and these get assigned like lookup values like 0, 1, whatever, and they have different samplers, and then there's different actual textures. So basically you have a bunch of samplers for different sizes of texture arrays, if that makes sense. So this is pretty easy to assign whatever icons we want. And here's a part of the design which I think works well. So when you're initializing a button, you can use this click function, which takes these two mutable structures here, and In this case, very, very simple. Just if it's open, add a message to close and then set some state. And then if they're both not open, then open it. And that's pretty much it. And again, using this constant here, so it's not end up being a closure. Menu button, yeah, this is the same deal. Still uses the same hovered effects and just a little bit different as far as the click goes. And then they get added to the panel, and then the panel gets ran as its parent is the screen space, and it's fine. And then if we look, for example, at the hotbar, this is a little bit different because we're actually just looping through and creating the buttons not in such a static way, but same deal, basically copying over the UI effects, which are just some color changes and some transparency changes, and creating a text box per button. This text box just has like the 1, 2, 3, or 4, whatever. And outside of here, actually assigning the textures. So you can see I have this size 256. I'm not using a 64. And this will get abstracted out later into like the network update to actually set the hotbar for whatever the user selects. And then a final thing to show with this is if we look at the health bar, this is slightly different, pretty much the same principle, which is creating a panel, except here it's just a tile. Tile is just like a textured or colored quad, doesn't do anything else really. And in here, we add a text box for the actual health text, and we have something called the data updater. So this is pretty cool because what this does is as data is updating throughout the system, it has a couple states unchanged or changed. And essentially, if it's changed, it can go through, and because we're passing in this panel, and actually it's not passing in panel, it's passing in self, so buttons would have their own reference, it can update its own subtree pretty easily. So that's exactly what this is doing. So you have panel text boxes. This is again a constant, so it's not a closure, and it's updating this panel, this text box to show the health correctly. And then this is a little bit confusing perhaps, but basically updating the tiles positions to kind of shrink as the percentage goes down. So there's probably a better way to do this, but this I think works fine. So whenever the data changes, it will go ahead and do this, but not if the data is not changing, so the player's not getting damaged or whatnot. And that's pretty much it. So we have button clicks for functions, we have data watchers, and that's sort of the part of the synchronization for the retain mode. And yeah, that's pretty much it as far as the design goes. There's little technical pieces like how to actually calculate the quads and their positions relative and all of that good stuff. Some technical details about the shader and how it's sampling. But I think for the most part, this is the general idea. And I'll definitely be improving on it in the future. But for now, I think it works fine. For the next devlog, I'll be working on more gameplay features, like the inventory, and hopefully be able to kill something and pick something up. Yeah, if you've watched this far, thank you so much. I appreciate it.